Good afternoon, everyone. Thank you for joining us. We have a full house again today. My name is Marissa Waterman, and I'm the Marketing Director here at the Academy. First off, we'd like to thank Freese & Nichols for financially supporting this webinar. You can learn more about them at freese.com. Here with us today, we have Dr. Viraj De Silva, a board-certified engineer and the Senior Treatment Process Engineer at Freese & Nichols. Dr. De Silva will be discussing regulations, sampling, and operating PFAS treatment systems in the U.S. Also joining us today is our Interim Executive Director, Dr. Daniel Uther. Dr. Uther will be serving as the moderator today when we get to the question and answer portion of the event. At the end of the presentation, you'll be able to type your question into the attendee chat panel on the left-hand side of your screen. We'll answer as many questions as we have time for, and you're also welcome to email Dr. De Silva directly. Okay, let's get started. Dr. Uther will say a few words and introduce Dr. De Silva.
Thanks, Marissa. Appreciate it. Friends and colleagues of the American Academy of Environmental Engineers and Scientists, welcome to today's webinar. It's offered with generous financial support from Freese & Nichols, and we really appreciate them stepping forward to sponsor today's webinar. One of the things we're doing with webinars is making these as a free activity to members, and that's only possible due to the generous financial support of those that see webinars as an important activity. If you're an individual or an organization and you'd like to sponsor a future webinar, please reach out to Marissa or to myself, and we'd be happy to discuss with you your opportunities. Today, we're going to listen to a presentation by Dr. Viraj De Silva. He's going to speak with us about regulations, sampling, and operating PFAS treatment systems in the United States. As we're all aware, PFAS is becoming an increasing problem. It's been around with us for a while. It will be with us for a while in the future. And recently, the US EPA has made some new regulations or proposed promulgating some new regulations about new levels of detection, new levels of treatment, where the human health risks are associated with PFAS. We're going to listen to a presentation by Dr. De Silva, and I would encourage you to share any questions you have in the chat online. At the end of this webinar, I'm going to help to moderate a question and answer session. So I'll be trying to summarize and pull together some of the threads from your questions. Dr. De Silva leads Freese & Nichols Treatment Process Services. We're fortunate to have him speaking with us today. He has more than 30 years of experience, and recently his article was selected as the Best Paper Award for the 2021 AWWA Membrane Treatment Competition. He has tremendous experience dealing with the problem of PFAS. He's published nearly 200 different articles in journals and conference proceedings. He's active in many organizations, including WEF and AWWA, ASCE, our Academy, and elsewhere. In particular, he currently serves as the Task Force Vice Chair for WEF's PFAS Task Force. Viraj received his doctorate from Northwestern University. He's a licensed professional engineer in 6 states, and he's proud to be a board-certified environmental engineer. And today it is my honor to introduce him and turn the floor over to Viraj. Viraj, thank you for joining us today.
Thank you, everyone. Good morning and good afternoon. So today's talk, I'm going to switch off my camera so you get see the full screen.
Do you need me to put back on the presentation? There you have it. Okay.
Today we are going to talk about EPA's latest health advisories, and then I will move to UCMR 5 program updates. And then we will go to talk about the PFAS treatment systems operating in the United States. Touch a little bit on biosolids and NPDES permits and impact from the PFAS regulations and industrial pretreatment programs that some states are already initiating due to PFAS, and then how to manage the concentrate. So PFAS, as you know, right now they are estimating more than 9,000 chemicals starting production in 1940s. The carbon fluorine bond is the strongest, one of the strongest and hard to break. That's why it is resistant to heat, oil, and water. And then these two chemicals, PFOA and PFOS, are the most studied chemicals that will be regulated pretty soon because of some health issues related to cancer, blood pressure, cholesterol, and immune system, as well as other diseases related to PFAS. So EPA came up with a roadmap, and we are soon expecting to have enforceable drinking water limits, which is MCLs under the Safe Drinking Water Act. Probably these regulations will come in the next 24 months. There is a possibility that PFAS, some of these compounds will be classified as hazardous under CERCLA, and also a lot of monitoring going on the drinking water systems in the United States. There is a possibility of GenX having in the toxicity assessment studies, and then maybe that might be a next chemical that EPA will regulate, as well as the EPA also are looking at air emissions that contains PFAS. So in June this year, PFOA and PFOS has lifetime health advisories of 70 ppt parts per trillion. In June, they have lowered that to 0.004 for PFOA and then 0.02 to PFOS. Even these limits, the lowered health advisories, are non-measurable, meaning you don't have lab methods to detect this low. EPA has lowered this, and I hope that in the future, in the coming future, there will be methods to measure these chemicals to lower limits. So where these PFAS is coming from, major sources I have shown here. Aviation industry, like the airports, use firefighting foam. Landfills have consumer products that all end up in landfills, so the landfill leachate definitely have some concentrations of PFAS. I'll show you in a slide what levels we have seen. Firefighting training facilities and firefighting stations and vicinity will have these, especially on the training exercises, they use the firefighting foam. So there might be some contaminations in the soil as well as the groundwater. Wastewater treatment plants, effluent might contain, as well as biosolids because of the industries that discharge to that sewer system. Also, dry cleaning facilities have, some of states have measured PFAS levels around dry cleaning facilities, groundwater and soil. That has been detected elevated levels. So FDA has tested in some parts of US food. They have found PFAS in high PFAS levels in chocolate cake, fish and meat, where the water is contaminated with PFAS. Also, the water consumed by cows have milk that is contaminated with PFAS. Also, some greens like kale, which has uptake the biosolids, land applied biosolids, have seen PFAS levels, high PFAS levels. in these products. But not all of these products are PFAS contaminated, especially if you are not in an area that the water or the biosolids are not contaminated. These are only related to some parts in the United States. So you can see from this map updated in June to 2022, EWG website, it shows about 2,900 locations in 50 states that has been contaminated with PFAS. These can be, the purple dots are the military sites, the blue dots are drinking water. Somebody might ask why some of these states doesn't have much and the others have more contaminated sites. That is because they have already sampled and they have the data, these states, and especially like North Carolina is a lot of universities is doing research, so they have done a lot of PFAS sampling, so you have more data. Now the EPA has moved to test PFAS in drinking water throughout the United States. These blue dots will turn into other states as well in the future. So what are the pathways PFAS get into our source water, which is surface and groundwater? On the right left-hand corner, you can see the firefighting foam here. That is used in military sites or airports or fire training facilities, could run off as to the surface water bodies, as well as it can contaminate groundwater as well. The industries like metal platers, carpet manufacturers, or food cartoon manufacturers, and leather, like shoe manufacturers, they might have PFAS applied to their products, and then they might be discharging their effluent to a wastewater treatment plant. And that might, because there is no regulations, wastewater treatment plant might be passing the PFAS into biosolids as well as in the effluent. Some of these solid parts might be ending up with landfills and landfill leachate. There is a possibility that they will be discharging either to their own river through an NPDES permit, or they will be discharging to a wastewater treatment plant. So that's another way that wastewater treatment plant may get PFAS. So these biosolids can be right now applied to farmers or land application, can contaminate not only groundwater underneath them, but also agriculture runoff to surface water, which will end up in the potable water sources that we consume today. So UCMR 5 is a program that EPA regions are right now requiring the water providers to test PFAS compounds in their water that is supplied to their customers. So there's a timeline here shown. It started in this year, but the sampling period starts in 2023 and go until end of 25. So it's 36 months. These customers that got email from the EPA region, there are about, I would say, over 10,000 water providers across US got these emails, and they have to sample their product water, which is that is going to the customers for a duration of 12 months. So it's a floating 12 months period. Within this 36 months, they have to sample their groundwater and surface water to check whether there is any PFAS. Now, PFAS compounds, there are 29 PFAS compounds on the UCMR 5 program out of the 30. Normally every 5 years, EPA establish these compounds. This time, EPA also include 29 out of 30 chemicals they are testing. So it's very important that PFAS is, they want to check the PFAS in drinking water. So you can see from this UCMR, which is unregulated contaminant monitoring rule, 29 compounds, as I mentioned, and lithium, they are using different, they have already classified some EPA methods to measure these PFAS. Some of them could be, some of them some of these PFAS compounds are measured through the EPA 533 method, and then another rest of it is measured through 537.1. So the communities they have selected, small communities, which is about 800 or less folks, fewer than 3,000. They have, fewer than 3,300. The EPA selected 800 communities. Between the 3,000 and 10,000, they have selected about 5,150, and over 10,000, about 4,000. So altogether, 10,000 communities got these letters, and they are going to test via labs that EPA has certified. There are about 20 plus labs in the United States that they can go and do the testing. Cost of this testing is about $750 per sample. So first I'm going to talk about North Carolina, because the Cape Fear River was contaminated with Genex by Chemours. A spin-off of DuPont was discharging Genex to this river, and this river is important because 19% of the North Carolina's watershed is under influence of this river. So Genex is found in this river from the studies done, and then the water utilities that are using source water from Cape Fear is they are taking measures to remove these PFAS compounds, especially Genex and others, from the source water, because it is an issue and a problem in the state. So, and also North Carolina State University recently released a study. One of the creeks, Greenfield Creek, connects the Greenfield Lakes. So connect the Cape Fear River actually water. So the alligators in this lake got sick, and when they get sick, it takes a longer time to cure than normal any other alligator. So the wounds have taken longer time, and they check the blood from these alligators, and they have found very high levels of PFAS in their blood. So not only alligators, but also earlier you have seen the slides from fish and deer. So there are in Michigan, there are signs near lakes: don't fish in this lake, or don't eat deer meat in some of the woods, because they are drinking PFAS contaminated water. So this chemours in the factory, the production of these chemicals also had air pollution issue, because of the air contained PFAS. So in 2018, they did an air study and also rainwater study within 7 miles from this facility. So in the middle, the white dot here is actually in the middle. That's the manufacturing facility. And then they found PPB. This is Genex, parts per trillion, parts per trillion. um, on even 7 miles away from these facilities. So how did they get this rainwater? Because of the air pollution, the clouds, and then the people have seen polluted air from these facilities. And in 2019, the DEQ North Carolina, they got some strict measures to reduce PFAS release from this facility to air as well as water. So thermal oxidizer was installed to remove the PFAS emissions, and they have been removing more than 99% of PFAS to the released to the air from this facility. This is a graph shown in one of the water treatment plants. The brown color line shows the raw water concentration of PFAS on PPT, and the blue line next to it shows the finished water. So this plant didn't have a mechanism to remove PFAS. So basically they are passing the PFAS. This is from 2020 to 2021. They are passing the PFAS without any treatment. And they are providing this water from this treatment plant to about 200,000 people. So what they are doing right now is they are adding a treatment system, especially a reverse osmosis system, to their existing plant to remove PFAS, so that finished water have no PFAS in it. So that's a full-scale reverse osmosis plant. Capacity of this plant is 36 million gallons per day. They are spending about 99 million on capital cost for this plant, expecting about 3 million operation cost, and this will be in operation next year. Similarly, another plant called Sweeney Water Treatment Plant, also source water is from Cape Fear River. They already have, in the existing plant, they have about 14 biological filters that also contain some GAC, granule activated carbon. As you know, granule activated carbon can remove PFAS, but this is not a full-scale granule activated carbon. So they have seen in this plant at least removal of less than 40% of PFAS in the existing plant. So they are right now upgrading that and spending about 43 million for the upgrade to install 100% removal or to non-detect level the PFAS removal system. Right now, what they are doing is they are adding 8 granular activated carbon filters. Out of the 8, 6 will be operating at a given time. So you can see from this photograph, there's like very big tanks, filter basins, I would say 8 of them, 4 each side. This is the new addition, and each one is about 12.5 feet by of granule activated carbon, and then 14 inches of gravel. They are expecting each of these tanks will run for about 300 days, so a little bit less than a year, and they have to change the granule activated carbon. Expecting they only need about 6 at a time, so they built 8. Maybe one is like a standby, and the second one, the 8th one, they are just keeping that filled with GAC if they have to fill or replace some of the parts of the GAC while they are in operation. The GAC part is about 36 million, and there are other components as well, capex, and then they are expecting, recently they published about $5 million per year they have to spend on these. These are huge granule activated carbon basins compared to the other ones you may have seen like the vessel ones, they are small. These ones are very big systems. And so another recently complete project in Alabama. This is in Decatur, Alabama. West Morgan, East Lawrence Water and Sewer Authority has installed reverse osmosis systems in their existing plant, conventional plant, and because they are taking the water from Tennessee River, so the source water is coming from Tennessee River. They upgraded this with reverse osmosis system, followed by a granule activated carbon filter. Cost about $30 million to do this upgrade, and they are operating almost 8 months right now. December was the start date, so they are doing they are treating these PFAS compounds to non-detect level. The 30 million they have spent so far is paid by the polluters. The fully so they didn't spend their own money. They had a lawsuit and they were successful to secure that money from the polluters. Some of you may have seen this one. This is one of the four operating plants by Orange County Water District in California. And this Orange County Water District provides to 19 cities and retail water districts water from predominantly from their groundwater systems. And then out of that 19, 11 of these communities have impacted. So they are building a number of PFAS treatment systems. They did an excellent job of doing some pilot studies. After the pilot studies, they decided to go with ion exchange, particular ion exchange, because they had maybe a dozen different manufacturers from different granule activated carbon, ion exchange and reverse osmosis, but they decided this is the best method to go with, and they have a number of treatment systems to remove PFAS. This is one of them. This is started about a year ago, 4.3 million gallons per day facility, and they spend about $3.7 million. It is in Fullerton, California. I have shown here some landfill leachate PFAS concentration ranges. This is a study that is done by Michigan Waste and Recycling Association a couple of years ago. And in this report, they did a survey and find out two PFAS chemicals, PFOA and PFOS. What's the concentration ranges in Michigan landfills of these compounds, and average concentration ranges in the United States, Europe, Australia, and China. You can see Michigan has, at least for the PFOA, if you look at a little bit less range compared to the other US landfills. You can see also in Europe, the levels are less, especially on the PFO range. But if you are looking at China, you can see very high levels of PFAS in their landfills. So the worldwide take a range, you can see actually PFOA has a higher number than the PFOS. Right now in United States, most of these carbonate chemicals or C8 chemicals, the ones that are more, done research, they have been banned in United States, but in China and other places, they are not banned. So there's a possibility still some products imported from those countries and sold in United States have PFAS compounds. So, but that will change once the EPA have some regulations coming up with the PFAS compounds. That will FDA and other organizations will ban import products with PFAS as well. So this is one of the landfills in North Carolina. I just wanted to give an example. What's their landfill leachate levels? Influent total PFAS is about, this is the total, not PFA, not only the PFOA, PFOS, but total, about 12 to 13,000 ppt coming in the influent of this landfill. It's called New Hanover County Landfill in Wilmington, North Carolina. So they had a lagoon and a package plant here in this picture, and they have their own NPDES permit to discharge to a creek in the background here. So reverse osmosis plant was built to remove arsenic as well as PFAS right now compounds, and then we have measured the effluent non-detect levels of PFAS. Actually, North Carolina DEQ, they have measured, also come and measured it. And this is one of the advanced PFAS removal systems. It's a small plant, about 75,000 gallons per day treatment plant, and then they spend about 4 million on this facility, and it is operating still from August 2018. So what are the methods that you can manage the concentrate? Some of the states right now are using deep well injection systems, either their own or the third party. So the third party in some states are charging if you have concentrate transport to their facilities. Some states have their own landfills as well as maybe wastewater treatment plant have their wastewater treatment systems, and that they have a discharge method through deep well injection in their systems. Other states might be still maybe sending these PFAS waste to landfills. That might change in the future, especially if the PFAS is classified as hazardous waste. Also, some states, because there is no Title V requirements on the air, they might be incinerating, but some states already have bans. For example, New York to burn PFAS in their incinerators. So there's limited methods right now to manage the concentrate or the PFAS waste, but research is underway for PFAS destruction by several universities. So there is a possibility that these technologies will come to full scale maybe in 5 to 8 years from now, and that way you don't have to deal with this PFAS waste. But for now, people who has the waste has to do something with their waste, especially if you are running a reverse osmosis plant. NPDES permits, it's maybe coming into the NPDES permits coming into their wastewater treatment plants. This is an example of Massachusetts, how they have already included just for reporting. So it's only monitoring right now once the MCLs come, and if that effluent of that wastewater plant is discharged to a river upstream on a water treatment uptake intake, then you will have some strict guidance, strict rules on these wastewater effluent limits. So right now, some states already put the this as a monitoring for monitoring. but other states still may not put it into even for monitoring. They are waiting until the MCLs are out, and they are waiting for that to come. So this can be expected in your facility, in your community, in the next renewal or the 5 years after the next renewal. So maybe within the next 2 cycles, there is a potential that your NPDES permit will have these limits, because in case you have PFAS sources coming into your wastewater treatment plant. So therefore, industrial pre-treatment is very important to have in your community to identify the PFAS sources. Maybe you may have some industries unknowingly discharging to your sewer system, such as dry cleaning facilities and metal platers and other chemical manufacturers. Right now, Michigan and Vermont have programs outlined statewide, and also some are already implementing these programs, but others are still waiting. But it can be nationwide once the MCLs are established. This is an example that Michigan did at some municipal wastewater treatment plants in 2 years ago. They had some PFAS coming into their wastewater plants. You can see from the second column, the PFOS effluent from the industries are very high. So what they did was they went and install different treatment system at the source. So predominantly they did granule activated carbon at the source, so they don't get it into their wastewater plants. So you can see that PFOS reduction is around more than 89% at the source. So they were able to reduce the source at the industrial facility. And the last one, you see this 49%. That means that's a blending. That's because they have a landfill that they can't eliminate 100% coming into the wastewater plant. What they did was they asked, instead of whatever the volume they are getting, reduce it by half. So that's why 49% is, let's say they are getting 50,000 gallons per day. They said you have to reduce by half, 25,000 gallons per day, so that they can reduce that in the wastewater effluent by dilution. This is another study Michigan has done from the industries. The orange bars here are the normal biosolid concentration that is coming up. What is the PFOS concentration in the biosolid or the sludge? So the number for the non-industrial discharge wastewater treatment plants. So these wastewater treatment plants doesn't have any industrial impact on PFAS. So they were like 13 micrograms per kilogram average number. But when you have industries that are discharging to the sewer system, the number jumped for like 195 micrograms per kilogram. So what that means is you have to do something here. These numbers still they haven't they will come up with some number to test your PFAS in your biosolids, especially if you're land applying. So they will come up, they means the EPA will come up with some number, and these ones has to be somehow reduced either at the source, or you have to do some treatment before you land apply. So this study shows the impacted industrial impacted biosolids. What's the PFOS concentration? So some states, they did a survey, WEF did a survey, uh, how much extra are you going to pay to your current biosolids handling cost? So this is a wet ton, how much dollars you are spending now, which is the blue line, blue bar here. And the orange bar is after the, if you have PFAS in your biosolids, what are you going to, how much is your cost going to be to handle these other the biosolids? So you can see some states, maybe this the N is how many wastewater treatment plants they surveyed this. Some are one in like New Jersey and Arizona and California. Some states we've got answers from several wastewater treatment plants that are handling biosolids. So you can see the percentage jump when you have the PFAS. So 69% increase. There is maybe they have in this case Massachusetts, maybe that some of these plants have maybe hazardous waste landfill nearby, and maybe there is not much cost difference, but others you may have to, like Arizona, they were talking about maybe 128%, but they may have to go to like maybe 200-300 miles to discharge PFAS if they can't maybe control the PFAS coming from there. So this is just to give an estimate. So it's better if you are in a municipality and you have biosolids right now, land application, it's better to have a plan for future. What will happen if you have PFAS? What are the methods? Because the current program or the current contractor who is taking care of your biosolids or taking to a farmer may not be able to do so if you find PFAS in the system. So to summarize my talk, EPA roadmap shows specific goals, and we are expecting some enforceable limits for PFAS in the next 2 years. PFAS has been found in drinking water, groundwater, soil sediments, and wildlife in the US. PFO, AFFF is a major source, and they are coming from fire training sites and military sites. And also, it is important that you talk to community about the risks and expose some of the websites I have seen in public the water quality. Not only they are reporting the water quality, also some of the cities have publishing PFAS levels in their websites because of I think communities want to know every quarter what's going on and if there is anything related to PFAS in the waters. And also, if you have potential risk of having PFAS either in your wastewater, water, or biosolids, or even air, you have to have a path to have these releases under compliance. Treatment of wastewater, PFAS in the wastewater is challenging. So, and also you have PFAS, would have PFAS in the biosolids. So it's better to reduce the PFAS coming at the source. At this time, some of these separation technologies, granular activated carbon, reverse osmosis, maybe some nanofiltration and ion exchange, but very good PFAS removal.
Okay, I think we might be having some technical. Oh, there we go. You back?
Yeah. So hold on. Yeah, sorry. And then I think lastly, I want to tell that include PFAS in your industrial pre-treatment program. There is no many, maybe I think majority of these industrial pretreatment programs doesn't have PFAS reduction or measurement or compliance. That needs to be considered as well. With that, I will take any questions. Again, I think if there's many questions, if I miss anything, you can take a screenshot here and then maybe send an email to me. I will try to answer. Thank you.
Excellent. Thank you so much. I already see some questions coming in. So Dr. Arthur, you can get started whenever you're ready.
Well, I'm ready. I was wondering, do we want to take the slide down and see Viraj and I talking, maybe, if that might be good, but we can also do it with the slide up either way.
Sure, that's fine.
There we see Viraj. Well, let's see if it's not. Oh, well, but at least we've got you on the hot seat, Viraj. So that works. That works. We can at least see your smiling face, even if we can't see mine. But that's okay. You provided us with a tremendous amount of information. What are PFAS compounds and other kinds of compounds in this next generation? Some of the action levels, some of the treatments. You've discussed this at the national level and the state and local level, and you talked about the multimedia we work with, including presence in wildlife. So there's been a lot of questions that have come in, and I've kind of grouped them. There's some general questions. Of course, people would like access to your slides, and we've already provided them with that information. But we've got questions that are about health, about regulation, and about treatment. So let me break these down a little bit and share. The question around health. These compounds are so unreactive. That's one of the problems, right? So what's the mechanism for these impacting human health? I mean, what do they do in our bodies that we worry about these things if they're just generally so unreactive? So what's going on? Help us understand more about the health consequences of these.
So first, we need to understand why the PFAS compounds are here. So in 1940s, when the 3M, DuPont, they created this chemical, they want a stable chemical, they want a heat-resistant chemical, water-repellent chemical, and they want to stay a longer time. So that's why they created this chemical. The 3M, and when they created these chemicals, they never thought it will enter humans. So now what happened is once you consume, somehow get into your body, it stays for ever. So that's why they are calling it forever chemicals. So it is not exiting, it is accumulating. So it's bioaccumulating. So it has health impacts. Cancer, colon cancer. There are a number of lawsuits right now related to workers that worked in these communities, and also people that have lived near Air Force bases or firefighting training facilities, and they had their private well, and they didn't know they had maybe 20,000, 30,000 parts per trillion, when right before that it was 70 ppt was the health advisory limit, but they were drinking that. Some people have died and they didn't know that. So I think the chemical is blocking some of this activities in the body. I can't go to like specifics what's happening, but there are so much research work the EPA and the lawyers are using right now, going on different in the medical side. Why it is there? I believe because it is stable, it is not leaving our bodies. It is doing something in our immune system. For example, latest studies has shown the young kids, like teenagers and low, below, like young kids get less effective for the immune system by, for example, COVID vaccine. So if you take the COVID vaccine, a young kid, it may be not 100% will block the COVID. I mean, it may be effective only maybe 60%. So there are some studies, those guns. I think I can't go to like analyze the medical, but I think the chemical is so stable, it is not releasing, it is not going out of your body, it is there, and then it is blocking some activities in our bodies.
Fair enough, Raj. Thank you so much. Yeah, I didn't want to put you on the spot, because I mean, it's hard to know everything about engineering and everything about health at the same time. But thanks for taking a shot at that. When these are going to get into a space that I think this next set of questions that I think will speak, directly to the strengths. Let's start with some questions around regulation. Now, there's an EPA roadmap. And we're thinking these things are on the horizon, but practically speaking, what's the limit of detection out in the environment? I mean, people are talking about these, astronomically low levels that maybe you might be able to measure in the lab, but how in the world are we measuring these actually in real environmental samples? And how do the regulations relate to the practicality of actually measuring these things and showing any effectiveness of our treatments?
Yes. So it's a very good question. Right now, you can detect up to about 1 to 2 ppt. That's all you can do. So if you are below like 2 ppt, parts per trillion, again, parts per trillion. Trillion means 1 part per trillion is take a 1 drop of water and drop it into 20 Olympic-sized swimming pools. That's parts per trillion means. So if you can measure, someone can measure today, not today's measurements to non-detect, that means it is below 2 ppt. So that's the number. And then I'm thinking that technologies will be developed in the future to those astronomically very lower number, which is 0.004 ppt. So why EPA did that? Most probably why they want to do is they are thinking this is bad. I mean, this is, even they can't put a number. But for the expecting MCLs in the next 2 years, I am thinking it will be single digits, like maybe 5, 6 or something in the single digits for PFOA and PFOS. Because they have to, if they put a number there, it has to be measured. So that's what I'm expecting right now. In the next 2 years, they will come up with, and you have to do something, I mean, to fulfill that. But the good news also I have seen in the recent, all these treatment plants I have shown you, they didn't go with a number. They said to the installers and the engineers, we need to treat to non-detect level. That means below 2 ppt, some number, something like that. So they didn't want to take a risk right now to lower it to some number, and then after 3-4 years, you have to lower it again. So they are taking measures to have their treatment systems designed and operate at the non-detect level.
Good, fantastic. Appreciate that. Now, along those lines, right, many of the treatments, since this is not actually a destruction, it's just a removal, then we've got, GAC that's now contaminated with PFAS, right? We have, reject water from our RO that's now got, okay, so what do we do with this stuff? Right? I mean, ultimately, it's got to go somewhere. So if treatment is just getting it out of our various streams, all right, now what do we do with it? Can you speak to that some?
Yes, good question. So right now, the established 3 methods we talked is granular activated carbon, ion exchange, and reverse osmosis. What happens on those 2 first things? The granular activated carbon or ion exchange, they are provided by a vendor. So this vendor comes in when let's say your cycle is about to change. Let's say it might be a year, it might be 6 months. You have to change that based on your water quality to get PFAS Now, all this, as you mentioned, that it's always all of those PFAS is attached to dielectric carbon or ion exchange. Now, what you do with it, that's the provider. What you do is the municipality or county or whoever is running, they have a service contract, probably about 2 to 3 years or more, signed with the provider. So he brings, let's say, the virgin carbon or the ion exchange, and then he takes the used or contaminated.
Viraj,
Yeah.
if I can interrupt you, it sounds like the audio quality got low. Maybe we'll go back to having you. Maybe if you turn off your camera, see if we get a little bit more bandwidth.
All right. Do you hear me now better?
It's still kind of garbled, but let's move forward and keep trying. So
Yeah. So basically, what it is the granulated carbon anion exchange, the provider service, the provider who is providing this media, they are taking it. Even if you ask from Orange County Water District, what are they doing with the ion exchange? I have seen a webinar like that in the past. Somebody asked that question as well. They said the provider is taking care of it. So you have a service contract. We don't know where he is taking. He might be taking to a landfill or hazardous waste landfill or regeneration facility. It might be longer run for them, but the cost depending on where they are taking. But the reverse osmosis systems, you have to take care of that. So what they are doing is the concentrate from the reverse osmosis, you have to do something. Right now, there are a couple of methods people are doing. One is if you're lucky, you have a injection well close by that you can inject it. The second method is the landfill I showed you. They are injecting back to the landfill closed cell. Another method in some states, they are concentrate again. They are taking another membrane and concentrate so that they get another very high, thick solid content concentrate, and then transport to a landfill or hazardous waste. So they the volume reduction. In the future, and also in some states, not all states, some states they use this concentrate. If you have a landfill, they used that concentrate mixed with a chemical and then used as a daily cover on top of a landfill. So it's like cement. It's more leach. It is like cemented hardened surface that they are using right now in Michigan and some other states. The EPA has approved, and also used internal roads. They are using that similar chemical. They are mixing it with chemical and then using it as a cover for the roads as well.
fantastic. That's helpful because I think where many of us are coming from is we're worried, right? If I pull this out of my wastewater and I do something where I dump it in my landfill and then I end up treating the leachate from the landfill, it's like how many times am I going to keep treating this same material and pulling it out, right? Because a few $billions in a piece of legislation is going to be a drop in the bucket when we come to dealing with this across the country. One of the specific questions we had here was in advanced, starting to think about direct potable reuse, right? So what are your thoughts about the accumulation of PFAS in those kinds of systems?
The direct portable reuse, yes. So if you are doing the direct portable reuse, lot of projects I have seen, when it leaves the wastewater treatment plants, um, they are removing PFAS at that effluent before they inject or if they send it to the water plant. If that's I have seen many recent projects. They are using different technologies to remove that before they are reusing that water. Is that the question? I think that's what I can say. Is that what you are expecting?
No,
Or
that's I'm trying, because again, I'm summarizing these from the stream of questions that have come in and trying to make, trying to find the commonalities. So certainly, you've introduced us to some of what the compounds are and what some of the health issues are, what some of the detection limits are and what some of the treatments are. And we as board certified professionals are trying to get our minds around it. So your presentation has done a great job of summarizing a lot for us. I guess you looking at the time and thinking about kind of the end of this, I think two questions people will have is one, what's the best way to get in touch with you to get a further information? And I believe you've got your slide up here at the end, and you're welcome for people to email you. You had already shared that. But if we are, as an environmental professional, looking to engage further in keeping ourselves up to speed and contributing to this discussion nationally about how we're dealing with these compounds, what would be ways that we can best engage?
yes, I think IT. There are several websites that that give up to date information and data. ITRC is one of the websites. If somebody wants, I can maybe email the maybe best five state websites to look at.
Excellent.
Uh, and also the map I showed, that will have all the contamination sites. They are the environmental working group. They are independent group. They are also updating the PFAS levels in United States in different cities on that map, and it is an interactive map. You can see the cities, you can see the levels, and so forth. I encourage people to go into that map. It is there's a link in my slide, and look at whether your community is influenced by PFAS.
Fantastic. Braj, thank you so much. And thanks again to Friesen Nichols for sponsoring the webinar today. This has been incredibly informative, and you've been very gracious to handle so many different questions. We had a lot in the chat, thanks to colleagues that posted questions in the chat and questions in the Q&A. I hope I did a reasonable job of pulling those together and summarizing them and to get some good information. Braj, just in summary, what I heard from you is that there's a lot on the horizon in terms of new technologies, in terms of limit of detection, in terms of regulations, and that there are opportunities for us as a community to get engaged and help learn and influence what's coming as outcomes from this. Do you have any final words for us as we wrap up?
I think, this is a lot to come in the next 2 years. It's critical when the EPA have limits on these, because we were waiting for years for that moment, and then because of that, there is many generations coming up. In the future generations, we'll have PFAS-free world, I believe, and the products that are produced right now will be 100% eliminated. But there will be some still residuals from the environment. So we need to, as engineers, we need to have engineering controls to remove or remediate those chemicals in the future. But the destruction technologies that the professors in a number of universities right now in progress, having seen a lot of good results. Those ones I hope will have in the full scale systems in maybe in about 5 to 10 years, and then we will able to not degrade but destroy, because when you degrade or you chop up the PFAS C8 chemicals, they are producing maybe smaller chain. Who knows? Those ones are maybe more also not good for health. But if you can destroy it to carbon fluorine atoms, that's the way to go. And I hope we will have a better environment in the future. Thank you.
Thank you, Braj. Appreciate your final words. Marissa, do you have anything to wrap up with?
Excellent. Thank you both. We have several webinars planned in the near future, so you can go to aaees.org/events to check them out and register. If you're interested in sponsoring an upcoming webinar, please reach out to me directly. My email address is mwaterman@aaees.org. And just a reminder, if you're not yet an AAES member and you're considering joining the Academy, please email me and we can discuss membership options that might be a good fit for you. And last but not least, the PDH certificates for this event will be sent out shortly. That's all for today. Thank you, everyone, and have a great day.
Thank you.
Bye-bye.
Well, that was